What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today we are going to pretty much just do a virtual contest around 670 just to see how much I could do. The last virtual contest of educational, I couldn't get the first problem. It is what it is, but you know what? I have to keep doing virtual contests, keep learning, and then just keep trying, keep trying different things. So let's see if we could figure out this problem. So yeah, I'm gonna try to figure out this problem. First, I have to close one of my computers because this is like, hold up, excuse me. We're waiting 3 minutes. In 3 minutes, we'll start doing that. I don't live stream at this time, but I'm kind of in the behind schedule in live streaming, so that's why I have to, try to get back on schedule in live streaming. But yeah, we're gonna actually every day I'm gonna actually live stream at 9 a.m. because I need to live stream. I need to do something in the morning and live stream. Otherwise, like, I'm not actually practicing competitive programming, and some days I solve a lot of problems, some days I don't. So that's a thing that I need to keep my eyes on, keeping tracked on, you know what I mean? But yeah, it's okay if there's not any viewers here right now. It's okay. I don't mind if there's no one watching. It's okay. These contests are, it's not just for me, it's not just for you, it's also for me, I need to get into the habit of doing this discipline every single day and trying to increase the competitive programming skill, and you could use the same thing for anything in life, like anything that requires discipline. You gotta try very hard. You gotta do the same thing every day. Otherwise, you're not gonna get any results. You know what I mean? But yeah. Normally I don't live stream at this time, but it's okay. It's okay. Yeah. Like, if I'm gonna make a video, then I might as well live stream it. You know what I mean? If I'm just gonna record myself doing this, might as well live stream. But if I'm gonna give explanation videos, then I would actually explain the problem. But yeah, I'm gonna do this live stream. I might actually create another video on what was it? So I'm taking this algorithms class that's teaching you design analysis of algorithms, and I might actually give some lectures on that, give some tutorials on those algorithms. So yeah, we learned something called stable matching, and I'll probably go over that in this next video. But yeah. After that, it's pretty much it. Yeah. So, it is what it is. Okay, what it is. It is what it is. What it is. But yeah, let's keep coding. Let's keep practicing, and then sometimes we will see certain results. I'm trying to get to green. I know getting to green, for some people it's really easy. So for others, it's pretty hard. For me, it's pretty hard to get to green. But yeah, I was green before, but then I dropped. So yeah, trying to get to green is hard for me. For other people, I mean, if you have like math background, like very good at competition math. I was never good at competition math, but if you did a lot of competition math, you probably could get to specialist very quickly. But yeah, anyway, let's go on this. Given a set of integers, it can contain equal elements. You have to split into two subsets. You want to maximize the value of mex. What does that mean? Mex is the smallest non-negative integer that doesn't exist in the set. Smallest non-negative integer that doesn't exist in the set. 1, 2, 2, 1, 1, 1, 2, 2, 0, 1, 2, 3. Okay, so if you sort it, and it doesn't exist in the set, then yeah, that's okay. So we want to split into two subsets. Smallest on a, we want to maximize the value of this. Maximize the value of this. So that means that let's see. Can't you just take sort it and take the last two elements? What do they want us to do? Maximize the value of the Like if you take, right? I think that would work. I don't know. Like if you take, okay, 0, 1, 2, 0, 1, 5 is a possible choice. So the maximum value is 5, 0, 1, 2, 0, 1, 2, so 0, 1, 2. Maximum value is not in the set. Wait, so if 0, 1, 2, 0, 1, 2, 3. Okay, so this would be 3. No, it would be 5. 5 plus 0, 1, 5. That doesn't actually make any sense. Hold up. Okay, so if we're doing 0, 1, 2, hold up, let me try this, okay? Let's write it out. We gotta write it out. Remember to always draw things out, okay? Okay, so if we have 0, 1, 2, 0, okay, so we have 0, 2, 1, 5, 0, 1, right? We have 0, 2, 1, 5, 0, 1. We want to split into two subsets where the two subsets for the smallest non-negative integer that doesn't exist in the set. So the smallest non-negative integer that doesn't exist in this set would be 3, right? And the smallest non-negative integer that doesn't exist for this set. Wait, hold up. 0, 2, 1. Okay, so they're splitting this up. A is going to equal to... What is going on with my pen? Well, that was a weird pen. Very strange. That was very strange. Hold up. Okay, so if we're splitting it by... If we're splitting it by 0, 2, 1, and then 5, 0, 1. So this is the set. And we're splitting it by 0, 2, 1. So we're going to have the first set, they said A is equal to 0, 1, 2. The second one is 0, 1, 5. So 0, 1, 2 is A. The second one, B, is 0, 1, 5. Okay, so if 0, 1, 2, let's just see what that did. So if we cut this out, so that was 0, 1, 2, 0, 1, 5. What is the smallest non-possible value that's not in the set? So here all the elements are in the set. So does this return 0? Here it's 2. Right? Because 0, 1, 2. 2 is not in the set. So this would return max of this would return this would return 2, right? This one, I don't know what this would return actually. They didn't say. Would it return 3? Yeah, it would return 3. Right, so then this would return 3 because 0, 1, 2, 3 is the smallest non-negative value not in the set. So if you add these up, it'll be 3 plus 2 would get you 5. But let's try sorting the first array up first. So let's try 0, 0, 0, 0, 1, 1, 2, 5. If I sort it and then I take the last yeah, if I sort it and then I split this in half, and then from this side I take the first half, smallest non-negative number that's not in here, so this would give me 2. And I sort this one, this would give me 3. So that's still the same. 3 plus 2 is 5. So let's try that, actually. Let's try that. I think, did someone enter the chat? Whoa. Sorry. I clicked X out something. Hi, how you doing? How you guys doing? Yeah, I'm just solving this problem of division 2 subset mechs. What I'm thinking is you could just sort it and just take the largest value that's not in the set. So that's what I'm thinking. I don't know how else you would do it, but do they assume it's even numbers? I think this would work actually. I'm not sure. Let's look at the second case. Because in the second case, if we split here, smallest number would be 3, it'd be 2. Oh wait. 1, 3. Wait. If we split 0, 1, 2 into 0, that'll give us 1. The smallest non-negative. Did you say non-negative integer? Does 0 count? Is 0 considered negative in this case? If for any integer number x, the number of occurrences of x into the subset equal to the sum of the occurrences of x into a, number of occurrences of x into b. Okay. Number of occurrences of x is equal to okay, so this is saying that if you split them up, the number of x's, there still has to be a number of x's if you split them up. Okay, but yeah, how you guys doing, by the way, in the chat? How is everyone doing? It's okay. YouTube's not okay. All right, let's just try sorting it and see if that works. I feel like that wouldn't work because the second case didn't work. Let's see. You have to maximize the value of max A plus max B. Maximize the value of max A plus max B, but you want the smallest non-negative integer that doesn't exist in the set. Decreasing order? Can we try that? Hold up. We could try the decreasing order. So let's say we have 0, 2, 1, 5, 0, 1. If I sort it in decreasing order, so let's do like 5, 2, 1, 1, 0, 0, and I split it in half. Smallest non-negative number that's not in here would still be it'd be 3. It'd still be 3. Smallest here would be 2, so it's still right. Yeah, so that's still right. But let's look at the other case. 0, 1, 2. So if I sort it decreasing order, I get 2, 1, 0. And if I split it in half, smallest non-negative would be 0 is non-negative, right? This would give me 0. This is going to give me 2. So this would give me total 2. But the answer is 3. Huh. Well, if you split by... Okay, it's 3 divided by 2 is 1.5. If I makes the ceiling, I get 2. So we split from 0, 1, 2. Well, if you split from 2, this would be 0. This would be 3. So maybe sort it and then split by ceiling? Let's try that. Let's go back to the first one. 0, 2, 1, 5, 0, 1. We got 0, 0, 1, 1, 2, 5. Let's see, 1, 2, 3, 4, 5, 6. 6 over 2 is 3. Ceiling of that is 3. Let's do 0, 1, 2, 3, 4, 5. Ceiling of that is 3, so we're going to do here, split here. So this is going to give us 2. This is going to give us 1. This is going to give us 3. Is that right? No, that's not right. So it's not ceiling. Definitely not ceiling. I definitely think it's floor, but it didn't work for the other case. 1, 3. No, wait, does it work? Three, 4, 4, 5, 3, 1, 5. Why is the last one not possible? 1, 2, 3, 4. Why is the last one output 0? 2 plus 1. Okay, 1, 2, 3, 4. Why is output 0? 2 plus, because this would be 2. This would be 1. This should give us 3. Alright, whatever. I'll sort it and then I'll just split by half, okay? And see if that actually does anything. I feel like some of these things are not actually right. So let's see. C and N, C and A. Okay, C and N, let's create a vector. Okay, let's just sort it. Actually, let's call in solved. Pass in, so I'm actually going to make this a global variable so we don't have to deal with this. Right? So I don't have to deal with the whole crazy ridiculousness. Whoa. Sorry, there's a fly. Vector. Okay. 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 Solved. Void solved. Okay. So now we have this. Okay. Now we need to. It's sorted. Is it sorted? Oh, it's not sorted yet. Let's sort. Then let's split it in half. So we'll do a dot size over 2. And that'll be one size and the other one is going to be another size. Okay, so we're going to have a dot size over 2. And then, yeah, so we'll like add that to one set, add it to another set. So let's create 2 sets. Set, let's call this first. Set second. Okay, and then now what we're gonna do is we're gonna go from to the middle and add those values. I took down a parentheses by accident. Okay, and then we do first dot insert. Now we're gonna insert the second values. This is actually going to start from a dot size over 2 plus 1. Okay, so that's the first half and that's the second half, and the second half we're just going to do okay. Yeah. This should be parentheses. Okay. And then we do second dot insert. Okay, and then now what we're doing is that we got to loop through the numbers from 1 to okay, so we actually need the maximum value to loop it up to, because that's the one then we could loop it up to. So yeah, let's pass in a max value here. Here, let's create a max value. This is going to be max value is going to equal to max of max val and a at I. And then we pass in max val. Okay, and then after that, let's just, yeah, so we're going to loop from 1 up to max val. Okay, and then if x is not inside the maxnum, if x is not inside the first array, then we break, and that'll be our number. So so if first dot find x is not equal to first dot end, right? If it equals to end, my bad, then we get our first that'll be the first value that's the smallest number that's not in the array. So let's call it val1 not. Okay, val1 not. And that's going to be val1 not. It's going to equal to x, and then we break. And then we do the same thing for if second dot find x find y is equal to second dot end, and then we need a val2 not. Val2 not. Val2 not is going to equal to y, and then we break. And then after that, we just see out val1 not plus val2 not. Okay. This should work, though I'm not sure if this works or not actually. Why set and not a vector? Set has no duplicates, and it's easy to look up. Vector, I have to do like traverse it again. Also, we're caring about no duplicates, right? Because we want the first number that doesn't exist in the set, right? So we don't really care if it's duplicated twice, right? Yeah. Let's see if this works. Okay, so we have 3, 4, 2, 5. Is that right? Oh, the first one should be 5. 3, 4, 2, 5. So we're a little off a bit. Okay, we're a little off a bit. Let's see. Okay, let's see our set for their sets. So the first set should contain 0, 1, 2. Crap. No. Why is it not working? Oh, so the first set should contain these values, because we're splitting by those values. Let me just rewrite it again. So we have 0, 0, 0, 0, 1, 1, 2, 5. 0, 0, 1, 1, 2, 5. 0, 0, 1, 1, 2, 5. And we're splitting right here. So the first two values should give me 2, and this should give me 3. Okay? So the first one should have 0, 1. So let's insert. See, first has 0. Second one should have 1 now. Yep, so we have 0, 1. Okay, now here it should give me 1, 2, 5. Okay, so this one should give me 1, 2, 5. So let's see. Second is give me 2. Okay, that's wrong. 0, 1, 1, 2. Yeah, okay. This should be not plus 1. All right, let's see it again. Five, 4. Whoa, negatives. 5, 4, negatives. 5. Okay. Why is it giving me negatives? That's weird. Okay. Let's look at 3, 0, 1, 2. Let's create a breakpoint here. So that means Oh. Okay. Okay. It's not just to the maximum number. We shouldn't loop to the maximum number. We have to do like a infinite loop here. Yeah. Sorry guys. Cause we have to keep going until we find a number that's not inside the set. Smallest number not inside the set. So yeah, let's actually do long max. Yeah. So while x is not equal to long max, then we break. Okay? So the maximum possible number long could be. Okay? Yeah. So we have to keep going until we find a number that's not in the set. So that's the reason why. 5 for what does that give me? Okay, wait, 5. This is wrong. 1 3. Oh, okay, yeah, this is wrong. 0 1 2. It should give me 2 1. Oh boy. Okay. This is wrong. 4 is wrong. Here is 0 0 1 2 4. This is right. 5. I don't know. I don't know why the last one's 0. I don't get it. 3. We should have, for splitting, this first one should be 2 3. Should be 3 0. So if they're already in sorted numbers, like if all the values are there, the answer should be n plus 1, right? Because we have 3 numbers plus 1. Yeah, right? I don't know. Let me read the chat. Try splitting. Let's say we have 1 2 3 5, and then 1 goes to A, then 2 goes to B. So I am reading the chat. Sorry guys. Am I reading this tutorial? I'm gonna stay on no sleep. Oh, sorry. No, you really need to go to sleep. You gotta go to sleep. You gotta go to sleep, dude. You gotta go to sleep. Try splitting alternating. Wow, okay, that might actually work. But I don't know if... Damn, is that the answer? Damn it, I was gonna split. Okay. All right, guys, next time in the chat, can you guys don't put like super duper hints, you know? Because then it just gets too easy. And it's like, you spoiled the problem for me. But anyway, it's okay though. I mean, if we're gonna split alternating, yeah, let's do that then. So if mod 2 is equal to 0, so I'm gonna split alternating. So the first one I'm gonna put all in A, second one I'm gonna put all in B. So this would split alternating. Yeah, that means this would work. Let's see. Why not split after the second 0? So the question is splitting and finding the first double element, I guess. 4 3 6 3 3 3. Finding the second 0. I don't know. Maybe. I'm gonna submit this. Let's see if it works. If alternating works, then you know, just try everything. You know. Oh wait. Okay, alternate didn't work. Did alternate work? 5 3 3 3. Hold up. Wait, how come in my answer I didn't get 5 3 3 3? Damn. Oh, I did get 5, 3, 3, 3, 3. That's not right. What am I doing wrong? What am I doing wrong? Don't sort it and then do it by alternating. That could be it. Because they're not doing... Pretty sure you have to sort it though. 001125. 001125. Wait, I was doing alternating though. 0, 0, 0, 0, 0, 1, 0, 2, 0, 1, 5. Wait. Was I doing alternating? 0, 0, 0, 0, 2. 0, 2, 1, 5, 0, 1. That would put 2 on the right side. No, that's not right. Is that right? Hold up. Zero, zero, 1, 1, 2, 5. If you split by alternating, 0, 0, 0. So these two, 1, 1, 2, 5. So that would give you 3 plus 2. I don't know. 2 plus 1 is 3. 0, 0, 1, 2. Did I try it before? What was it? Okay, so let's see. 0, 0, 1, 1, 2, 5. Let's see. What is the chat? By the way, I figured it out. Okay. Why not split from 2? By the way, I have figured it out. Okay. Not reading the chat. I am reading the chat. Why not split the second 0 as the question suggests? So splitting on finding the first double element. So 0, 1, 2, 5, and then 0, 1. So that would be 2, 2, 1. Which gives us 3. Well, then you get 3. 3 plus 0. Well, then you would get 0, 1. Okay. Yeah, I think okay. I think I get what you mean. Okay. So try splitting on until you find an element that's already there. Until you find a duplicate. So put everything in one element until you find a duplicate. I think that's what he means. Okay, so if you... Okay, so let's do a dot if first is equal to first dot end. That means it's completely ended, right? We got to find a duplicate. Oh yeah, so then we're going to insert first dot insert a of I. So we're not going to sort. Okay, so we insert all elements. If it's not equal to the end, so that means we're done. That means we have to insert the rest at second, right? So then let's actually break, and then insert the second values at second. So let's make I index equal to 0, and then here, this is really ugly, but I don't want to make it to a while loop, so I'll just do that. And then I'm going to loop from, so it didn't actually get incremented yet, so we have to do like I plus in j equal I plus 1, j is less than a dot size, j plus plus, and then we do second dot insert a at j. Okay, so this is gonna find the first occurrence of second occurrence of a number, and then it's gonna break. So all those values that are second occurrences of that number, it's gonna break, and then we have the rest. So we're gonna split at that point. Okay. So yeah, let's see what this actually gives us. So here we're gonna, what it's gonna do is, so here we have 0, 2, 1, 5, 0, 1, right? 0, 2, 1, 5, 0, 1. Why is something's wrong with my pen? So we have 0, 2, 1, 5, 0, 1. So this is gonna find the first occurrence of 0, and once it does, it breaks. So we split here. So then we're gonna have 0, 2, 1, 5 here, and then we have 0, 1. So then this is gonna give us, first non-negative number is 2. This is gonna give us 3. So we're gonna 2 plus 3 is gonna give us 5. Okay. Yeah, let's see what this, let's see our two sets. 0, 2, 1, 5 was right. This was gonna be 1. Oh. I didn't add the 0. Damn. Okay. I think I equal I. Yeah. 5, 4, 3, 8. Okay. 5, 4, 3. 8. 8 is wrong. Okay. Maybe. So for 8, it's going to split at, because we couldn't find any occurrence, so it splits at the last one. So it'll give us like 7. And then the maximum value that's not there is 0 and 0. So it would be 1, 1, 7, 8. Oh, okay. We should start from 0 then. Okay, let's see if this changes anything. Yeah, so now it's 0. Okay. I think that's right. Thanks for the hints, guys, in the chat. Splitting by until you see another 0. Okay, nope. It's not right. Let's see. What's the problem? Wait, but I got 4. Hold up. I'm pretty sure I saw 4. That doesn't make sense. What's going on? Hold up. Maybe if it doesn't contain 0, then you should just print out 0. Maybe that'll stop the case. I'm pretty sure I saw 4. Let's go back to 1. Let's see if we. Yeah, so there is 4 for the case of 1. See 4, 3. So this one, last one's wrong. I'm guessing if there's no 0 inside A, just print out if how do you find a vector? Oh, we could just do like bool no 0. So has 0 is going to be true. Has 0 is false. Actually, has 0 is false. If A is equal to 0, then has 0 is true. If there's no zeros at all, then let's just print out 0. I don't know if this case would work, actually. This probably will break something. Okay, I did not actually go through that, the whole cases. So this might actually break something. This could be wrong, but it might pass the first test case only. Okay, no, never mind. It still didn't pass the first test case. Huh? I have zeros though. 0. Oh. What the? If there's no 0. Okay. What was the problem? Number is different. For 3, expected 3, we found 4. Oh, what? Expected 3, found 4. Let me see. What is the answer? 5340. Oh. Split until you find a duplicate of 0. That'll give you 1 and then 3. So that'll give you 4. Okay. I was splitting by duplicate of a number, so maybe that's not right. Let's try to find, let's split until we have a duplicate of 0. Actually, we still need to have 0. What am I doing? Yeah, let's split until we find duplicate of 0. So if we find, so we're gonna keep inserting A until we find a duplicate of 0. Okay, so this one we're gonna find 0. Wait, okay. Okay, if we don't find 0 yet, we're gonna insert A. Otherwise, once we find a 0, that's not in, we break and then we insert it from there. Yeah, maybe this would work. Let's see. Max of another set. Try creating frequency arrays so you'd have the count each on the loop through decrease the count out when you count. If the count is 1, then that means you appear in one set. That means they're max in the next set. If you apply another 1, that means it will be max in another set. I will think of that after let's see if this works yet. Why aren't you running? Zero, 1, 2, 5, 4, 3, 4, 2 should be okay, so we're getting something. Let's see what the two sets are. So the first one is 0. The second one is gonna be 0, 1, 2, 5. That's weird. 0, 2, 1, 5. Oh wait, crap. Okay. I'm inserting 0 and then I check if does there already exist a 0. Okay, that's not right. We need to keep it. Okay, so we have to do while a of I is not equal to 0. No, that's not what we have to do. We have to find the first index where 0 doesn't occur and then split by that. So here we would have to do for so let's do like w is equal to 0. So while w is less than n, and W at A at W is oh boy, we have to keep inserting the values into here until we find a duplicate of 0. So if W okay, I got it. Okay. I got it. For int k 0, 0, k is less than a dot size, k plus plus. If k at k is equal to 0, so if we find the first 0, we are going to add all the values from here on until we reach let's just create an under for p. Okay, whatever. P is going to equal to k plus 1. Yeah. So P is going to equal to K plus 1. P is less than a dot size, P plus plus. We're going to, from that there onward, we have to check if A at P is not equal to 0. Then we're going to insert it into our array. Once it is equal to 0, we break. Okay. We break from our P and we add the rest of the array that is not there. So this is going to be, so here we're going to have first and second here. So first is going to be all the values from 0. So if it's equal to 0, we're going to insert it to okay. Here, it's not equal to 0, right, from the rest. So we haven't found another duplicate of 0 yet. We are going to insert it at A also. Okay? So we're going to do first dot insert at A. Otherwise we have to loop from the rest. So we have to loop from P plus 1 and add all those values to the second one. Okay? And then we break. So yeah, so then here we're going to do for int, I don't know, T is equal to P plus 1. T is less than a dot size, T plus plus. And then from then onward, we insert into second. Okay. And then after that, we just break. Here, we break. Yeah. I think this should work. And then after this one, we just break. But what if we never encountered any 0 though? So we have 1, 2, 3, 4. Then both sets are empty. If both sets are empty, should we just return 0? Right? Yeah. Okay. Yeah. So then here, yeah, that's it. Okay. Here, we do the same thing here. So this is the same. But what I'm going to do is if both sets are empty, yeah, if it has 0, if it doesn't have 0, we return 0. Okay. This should work. Ideally, it should work. Let's look at let's look at the sets after we do it. Damn, that's not right. Hold up. Max element. Yeah, I'm thinking about using a frequency array, but if I could use a set, I'll see if, because using a frequency array is technically the same as a set. 0, 1, 2, 3, 5. Second one should be 1. Okay. Oh, I didn't even. Okay. I forgot to insert the 0 from here, so this should be P plus 1. Yeah. Okay. 0, 1, 2, 5. This is going to be 0, 1. Yeah. Okay, so we have 5, 4, 5, 5, wait, 5, 4, 5, 0, 5, 4, 5, 0, 5, 4, 5. Ah, that's wrong. I need 5, 3. This should be 3. So 0, 1, 2 should give me 3, and then the other one should be 0. Yeah. What's the problem? Oh, okay, here. Yes, sir. Okay, 5, 3, 5, 0. Okay, so we're still getting some wrong. So 0, 2, 0, 1. Let's look at that. Let's look at that case. 0, 2, 0, 1. 0, 2, 0, 1. Let's see. 4, 0, 2, 0, 1. Let's see. So the first one is 0, 1, 2, 0, 1. Is that right? 0, 2, 0, 1. Let's see. 0, 2, 0, 1. 0, 2, 0, 1. It should be 0, 2, and then 0, 1. What did that give me? 0. Ah, that's not right. 0, 1, 2. It should 0. It should be 0, 2. One. What is the answer? Yeah, I'll use a frequency array after this. Assuming that sets don't work. But I just screwed up something. But technically you could use a set, I'm pretty sure. Because frequency arrays, the problem with that is that I don't want to 0, 2, 0, 1. Alright, we find 0, we insert 0. Then from here on, it's not equal 0, we're going to insert at 2. Okay, now it's 0, so now we're going to insert what did we insert? We did not insert it. Oh, did we? 0, yeah, we insert 0. 1 should be 1. Yeah, 0, 2, 0, 1. Ah, crap. Okay, here, then we break. Uh, 0, 2, 1, 5. Ah, why is it still 0, 2, 1, 5? 0, 2, 1, 5. Wait, hold up. Oh, 0, 2, 0, 1. My bad. 0, 2, 0, 1. Let's actually take this. 0, 2, 0, 1. 1, 4, 0, 2, 0, 1. Is it 3? Is that right? 2, 0. That's 4. 0, 2, 0, 1. Why is it wrong? 0, 2, 0, 1. 1, 4, 0, 2, 0, 1. Let's look at first. 0, 2. Second, 0, 1. Yeah, that's right. So val 1 should be 1. Val 2 should be 2. So that gives us 3. Okay. That's not right. That's not right. 0, 1, 2. So that's 1, 2, 3. Oh no. 0, 1, 2, 2, 1. 2, 1 is 3. Yeah, that's not right. Let's keep thinking. Keep thinking. This gives 3. This will give us 2, 5, 1, 0. Wait, no. 2, 3. 3 with a 0. 2, 3. 0, 2, 0, 0, 1. It's going to give us 0, 1, 2. No. 1, 3. No. 1, 2 would do this wrong. Yeah, you can't get from. I don't think you could just keep adding until you reach another 0. Because you get 0, 2, and that'll be 1, 2, which is not right. That would give us 4. That doesn't work. All right, let's see. Let me read the chat. Find the frequency of all element traverse from 0. Find the first element with a frequency of 0 or 1. Find frequency of all elements start traversing from 0. First find frequency appears. Wait, what? Okay, well he deleted it. Okay. Okay. Let's see. 1 is 2, 2 is 5, 2 is 1, 5 is 1. Find the frequency, keep adding until you find a frequency of 0 or 1. Let's see. Okay, I'll see what you're thinking about. So you're saying is that keep a frequency array. So do like so if the first one is 0, 2, 1, 5, 0, 1. So if it's 0, 2, 5, 0, 1, and the first one we have a frequency of 2. This one we have frequency of 1. 2 we have frequency of 1. 5 we have frequency of 1. And then if we keep decrementing, I don't know what you said. Keep decrementing. What'd you say? I guess I had a loophole. You have to maximize max of 0. Max of empty is 0. Max. Oh, this is pretty hard. Huh. I feel like we could definitely get the answer though. Okay, what was one of your comments? If the count of an element is 1, then it means it only appears 1 in the set, so that means error max, and that will be the next element. If this applies when you get a 1 count of 1, which will mean it will be the max of another set. So oh, are you saying that the max of one set is going to be equal to the size of the other? Is that what you're saying? Try creating a frequency array. You know the count of each element and loop through the array and decrease the count of the element in which it was encountered. Do I practice CP every day? I'm gonna try to. Try splitting, let's say 1, 2, 3, 1 goes to 2, 2 goes to B. You know, alternating way, try this. Try, I think I tried that. Didn't I try that? Didn't I try alternating? I mean, we could try it again. We try alternating again. No, that doesn't work. No. I don't think alternating works. Yeah, I don't know. Sort alternating? Pretty sure that doesn't work either. Does that work? 5, 1, 3, 0. 5, 1, 3, 0. Why does it give me 1? 0, 1, 2. 2 plus 1 should give us 3. 0, 1, 2. 1 plus, 1 plus 0. Oh boy. Oh boy. What if I try 1? Looping from 1, even though that's definitely not right. What was it? 5, 3, 3, 0. Nah. Oh boy. Okay. I'm pretty sure I tried that. Okay, like that's what I was doing in the above array last time. Hold up, I'll show you. That's what this was doing. Like if we find a frequency of 0, we add all the zeros, and then we loop, check if it's there. From that point on, we all add all the ones there. Yeah. I mean, I could code the same thing of what you say. Keep adding all the values until you find a duplicate. I think that's what you meant. I mean, I could do that. So, if first dot find a of I is equal to first dot end, so you don't find it yet. Yeah. So if you don't find it yet, we're gonna add it to first. Otherwise, if you already found it, we're gonna add it to the second set. We're gonna add the rest. So we're gonna add the rest. So we're gonna do int w is equal to k, w is less than k plus a dot size, w plus plus. Then after that we break. Yeah. Five, 3, 3, 0. That's not right. I mean, yeah, that's the same thing as doing before. Are you saying to include the 0 in the first set? Like if you... Hold up. As long as you have duplicate elements, you populate both vectors. As soon as you encounter a single absent element, you immediately break and include the rest in any one vector. As long as you have duplicate elements. It's as long as you have duplicate elements, you populate both vectors. As soon as you encounter a single absent element, you immediately break and include the rest in one vector. Sort it out for ease. So you're saying like 0, 1, 2, and then 3 is not in it, so we just break and include the rest. So keep adding values when there's no duplicate. Not no duplicate. Keep adding values when you keep adding values into the array starting from index 0, right? So 0, 1, 2, and then 3 is not there, so we break at 3, right? Isn't that what you're saying? So, okay. Let's try that. I mean, I'm not... So you keep adding values. So first I insert k. Yeah, k. Keep adding it until you reach... Okay, so if first is... Okay, so if first is empty, then we just insert it, right? If it's not empty... we need to check if first dot find so I have 0. We're gonna add 0, 0. Add the first value. Check if it occurs, if 0 occurs in the array. Right. So if first dot find 0 up to k is inside. Right. If it's not, then we break and include the rest. I think that's what you mean. So if you find so I need another for loop. So for int j is equal to 0, j is less than equal to k, j plus plus. So if k is like 5-ish, no, yeah. If first dot find j is not equal to if it's not equal to first dot end, so if we can't find all the values from 0 up to it, then we break. We break out of the for loop. So okay, so wait, okay, hold up. I think I get what you mean. So like you're saying like if we have 0, 2, 5, 0, 1, right? So if we have from here to here, we have to check if the wait, wouldn't it break out from here then? Because 1 is not in this set. So it's going to give us 0, 2, 5, 0, 1. And then this is going to give us 1. This is going to give us 3. That's not right. 1 plus 3 would give us 4. Oh, okay. So you're saying like all the values when we split up must contain 0, 1, 2, 3 for the length, right? If we're splitting here, it must contain it. So the third one, 5, doesn't contain 4. 1, 2, 3, 4, right? So then we split from there. So we're going to keep adding values to the first set, okay? And then we're going to keep checking based on the length of the set. Does all the values contain the, does it contain from 0, 1, 2, 3, 4? All right, so if it's size 4, it has to contain all values 0, 1, 2, 3, 4. If it doesn't, then we break, and then we can include the rest. I think that's what you mean, right? You break at 2. Should be 0, 1, 2, 0, 1, 2, 5. As soon as you encounter a single absent element, you break. Include the rest in any vector. Nope, you break at 2 because the first condition was to find the element with a frequency of 0, 1 first. You could construct a frequency array. Hi. This is taking a while. This problem is taking a while. Let's see. This is difficult. Very, very difficult. I wouldn't say it's like, I don't know. Maybe I should just look at the editorial at this point. I mean, we tried over an hour. Let's read the editorial. Store the count of each one in a count. Max A would be the smallest I for which the count is 0. Let this to be X. Max B would be the smallest I for the count is less than or equal to 1. This is because the count of each number is less than X would go to A. Therefore, the count of presently now would be available for B. Difficult. Okay, let's try that. I guess we're not going to use sets then, because they say you use count. So we're not using sets. Quite frankly, I don't really know what I'm doing. Okay, 0, size. Okay, you know what? Let's call it n because I don't want to deal with n. Oh, yeah, we have n. I don't know why I never used it. Okay. Let's take this n out. Okay, I'm gonna use a map count. I don't like using like a frequency array. At I plus plus. Okay. Actually, because it contains only integers from 0 to 100, actually we should just use a frequency array. Because then we could loop through it. So this is going to be 101. Right? Then we do freak at a at I plus plus. Okay. What did they say? Max would be the smallest I for which the count is 0. Smallest I for the count is 0. Smallest I that the count is 0. Huh? What? Zero, 2, 5, 0, 1. Zero's frequency is 2. 1's frequency is 1. 2's frequency is 1. 5's frequency is 1. Max is the smallest I for which 2 is 0. Wait. Smallest I for which the count is 0. Okay, so here we have 1, 2, 3. 3. 3 here, the count is 0. 4 is the count is 0. Okay. What will max be? Smallest I that the fifth count is 0. Max B would be the smallest I for which the count is less than or equal to 1. Oh, okay. 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 Less than or equal to 1. Smallest I which count is equal to 0. This I is going to be x. This is because one count of each number less than x would go to a. Oh, so we break at 3. Wait, then my set of earlier should have worked. Because for the set we were talking of whatever. This might be easier. The count of number less than x would go to a. Each number less than x would go to a. The count of each number less than x would go to a. So you're saying, so x would be 3. So all the numbers before 3 is going to go to a. So that means 0, 0, 1, 2 is going to go to a. And then 5 would be to b. 5. Oh, less than. Yeah. 5 would just go to b. So this would be a. Three plus 0 would give us 3. That's not 5 though. Let's look at it. Max would be the smallest I for which this value is equal to 0. Okay. Let this I be x. Max b would be the smallest I for which count of I is less than or equal to 1. The count of I is less than or equal to 1. One count of each number less than would go to A. So one count of each number. So this is going to be 1. This is going to be 0. This is going to be 1 minus 1 is 0. So we would have 0, 1, 2 in A. So A would be 0, 1, 2. 0, 1, 2. B is going to be 0, 5. Is that what they're saying? Next, B would be the smallest I for which count 1 is less than or equal to 1. Smallest I for which count 1 is less than or equal to 1. So 0. Oh, okay. I think I get it. Okay, so here, now we're going to go loop through from the beginning. And then we're going to decrement by 1. We actually have to find the first value that's equal to 0. So yeah, if A at I is equal to 0, we break x is going to equal to I. Now we have to decrement all the values from here prior to it. So during this whole time, we should have decremented frequency at A of I, because one of them will go there. Yeah, because then we're going. Yeah, okay. After that, we need to find the first value that is not, that's count is less than or equal to 1. So we're going to do for int k equals 0, while k is less than n, and k, A at k is greater than 1, k plus plus. So this is going to find the first value that is less than or equal to 1. Then we have k, then we just do C out x plus k. Okay, we get 0, 0, 0, 0. That's not right. Oh no, frequency. Two, negative 1, 2, 0. That's not right either. Okay, let's see. Okay, frequency here is 221,001, right? Frequency is 221,001. Now, the first number that is equal to 0 should be 3. So it's going to find, my bad, should find what is our x? 2. That's not right. Okay, we're not supposed to decrement. We decrement when we get when we're done. So like if a is 0 less than k, now we decrement. Okay. Then we do that. Okay, hold up. Why do you have to be so ridiculous? So x is now 3, and then now from 0 to 3 we decrement by 1. So now we loop through while it's less than or equal to, yeah. So this should be 3. Now it should give us less than or equal to 1. Max of b would be the smallest I for which count I is less than or equal to 1. Smallest I which count I is less than or equal to 1. So that would be 2. Ah, okay. Less than or equal to 1. No, but that would be 0. This should give us 3 plus 0. Wait. 3 plus 1. 3 plus 1. Let's see. 0, 0. Three plus 1. Smallest I that's less than or equal to I. Count less than or equal to 1. Your looping from frequency must be from 0 to 101. Well, we're not really. It's just a simple frequency array with 2 loops. Yeah, you're right. Wait, but your frequency array should be from 0 to 101? Maybe that's the reason why? Hold up. But then, like, okay, hold up. I still get 0. No, I got 3. Hold up. What? It's a frequency array with 2 loops. It's not just a frequency array with 2 loops. It's multiple frequency arrays, you know. It's more than 2 loops. Hold up. Let this I be x, okay? So that I is going to be x now, okay? X is equal to I. Max b would be the smallest I for which the count of I is less than or equal to 1. Is less than or equal to 1. We count e of each number would go to a, therefore I mean that's the same thing here. Okay, look, okay. I'll start at 0 and I break, okay. Okay. If frequency array at I is less than or equal to 1, then we're going to break. We're going to create a k. K is equal to, let's say, long integer underscore max. K is going to equal to I, then break. Okay, let's see if this works. It's still the same thing. Smallest frequency array. Max A would be the smallest I for which count is equal to 0. I did that. Let I be X. Max B would be the smallest I for which count of I is less than or equal to 1. Of each number less than X would go to A. Therefore, the element which was initially present once would not be available for B. Smallest I for which count of 1 is less than or equal to 1. Are we not decrementing the frequency? Nope, it's still not right. 5, 4, 4, 3. 3, 4, 0. First one should be 5. I got 4, 3, 4, 0. 4, 3, 4, 0. It should be 5. Why is it not 5? Let's just see. What are we doing wrong? Oh, 101? But that doesn't change anything. Let's see. From here. What is our X and our K? Out of range. Oh, wait, here is N. Wait. First value, that's frequency of I. Frequency of 1. The count of I. Maybe this would work now. Nope. What is the problem? Oh, this is N. Ah, okay. Now it should work. Five, 3, 4, 0. Yay. Okay, let's see if this works. 5, 3, 4, 0. Yes. Finally. Yay. Okay. Thanks, guys. Repeat the same, but this time you don't have to decrement and you have to take K when you have frequency of 0. Remember to initialize X here because there is a possibility of not finding such element. Okay, well, we got a seed finally. I think that's enough for today. Maybe I'll try the maximum product later, and then maybe link cut centroids. But yeah, rate, comment, subscribe. I'll check you guys later.